Hey everybody, Mrs. Syed here. I hope you guys all had a relaxing and productive spring break, and I hope you're refreshed and ready to learn some chemistry. So today's lesson is on the basics of stoichiometry. Our objective is to explore the types of relationships given from a balanced equation, as well as using the mole-to-mole ratio to perform stoichiometric calculations. So I'm going to go over a couple of slides and then I'll do a few practice problems for you guys. So the basic principles of stoichiometry, the main idea is the amount of each reactant present at the beginning of a reaction determines how much product can form. So stoichiometry is basically the study of quantitative relationships between the amounts of reactants used and amounts of products formed. It's based on the law of conservation of mass, which means that the mass of your reactants will always equal the mass of your products. Here's a chart that shows information that can be derived from a balanced chemical equation. So the example here is iron plus oxygen yields to iron oxide. So here, I made my cursor bigger for you guys. I don't know why it looks like 4 arrows, but if you look at each row, you can determine different information just from this balance equation. So 4 moles of iron and 3 moles of oxygen will yield to 2 moles of iron oxide. If you calculate the mass of the reactants equals the mass of the products, which makes sense because the law of conservation of mass. All right, mole ratios. So mole ratio is a ratio between the number of moles of any two substances in a balanced equation. They can be used as a conversion factor. So we're going to do some more conversion problems using mole ratios that we determine based off a balanced equation. So conclusion, when converting moles of a substance to moles of another substance, you use the mole-to-mole ratio that's given in your balanced equation. And please always make sure that your equation is balanced before you ever do any conversions to figure out the moles. Okay, so that's it for the slides. Now I'm going to show you a few example problems. All right, guys, so the first example problem I'm showing you is a simple mole conversion problem. So just label it like that, simple mole conversion example problem. The next one I'm going to show you is a problem where we'll be using the mole-to-mole ratio. So this problem states, to carry out a chemical reaction, you need 3.2 moles of zinc nitrate. If you were conducting this experiment, what mass of zinc nitrate would you measure out? So basically, the problem is giving us moles and it wants us to convert it to mass. And we know the unit for mass is grams. And this is important because if you were conducting an experiment, we can't measure out 3.2 moles on a scale. We measure out grams on a scale. That's why we need to convert it. So just like any other conversion problem, I'm going to set up my T. Okay, and I know what goes on the outside is what the problem starts with, right? What the problem gives me. So it gives me 3.20 moles. And because this is a conversion problem, I know that my units need to cancel out. So the unit that goes on the bottom needs to match the one on top. So I know that's going to be moles. And I'm solving for mass, which the unit is grams. That's what I want to end with. So the unit that goes on top is grams. So all that's left is to figure out what my conversion factor is. Now, in order to figure out the conversion factor, you just need to figure out the molar mass of zinc nitrate. Right? And we already learned how to do that. So if you don't remember, go back, look at your notes, or look at older videos. Don't forget to like and subscribe to my YouTube channel. I'm totally kidding. You don't have to do that. Okay, so I already know what the molar mass is. I already did it. So to save time, I'm just going to tell you it's 189.3 grams, 0.36 grams per mole. Okay, so for every 1 mole of zinc nitrate, I have 189.36 grams. And that right there is my conversion factor. Do you see how grams per mole matches grams per mole? So I'm just going to fill that in. So for every 1 mole of zinc nitrate, I have 189.36 grams. Now, you guys are masters at this. Multiply across, divide on the bottom. So you would get 605.952. For my units, my moles cancel out, and I'm left with grams, okay, which is what I want. Okay, so if you think about it, it's just a simple multiplication problem. You know that for every 1 mole, there's 189.36 grams. This problem's asking me for how many? 3.2 moles. So you just have to multiply that by 3.2. But this is how you do it by setting up the conversion factor. All right, so this next example problem is using the mole-to-mole ratio. So if you want to label it mole-to-mole ratio example problem in your notes, go ahead. All right, so the problem gives us a balanced chemical equation. All right, always make sure it's balanced. It is. And it's asking us to determine how many moles of Al2O3 are produced from 8 moles of aluminum. Okay, so we are going to use our mole-to-mole ratio, but just like any other conversion problem, I'm going to set it up like so. So I'm going to start with my T, sideways T, and I always put what's given on the outside, right? So what's given is 8 moles of aluminum. And for these problems, make sure to include all of the unit, all right? Be very clear, 8 moles of aluminum. And I know that for a conversion problem, I want my units to cancel out. So my units on the bottom need to match the top, right? So moles of aluminum is on the top, moles of aluminum need to be on the bottom. And then it's asking me determine how many moles of, I'm solving for how many moles of aluminum oxide. So that's what's going to go on top. Okay, moles. All right, so my conversion factor is set up. Now I just have to fill it in. And the way to fill it in, all you have to do is look at the balanced equation. Your ratio will literally just be the coefficients. That's it. So moles of aluminum, that's my coefficient. It's 4. Okay. Moles of aluminum oxide, that's my coefficient. It's 2. That's it. Simple as that. Now I just multiply across and divide on the bottom. So 8 times 2 is 16. Divided by 4 is 4. So it'll be 4 moles of aluminum oxide, right? Because these cancel out, those units cancel out, and I'm left with that. That's it. Simple, right? So basically the key to this, the way to use your mole-to-mole ratio is just the coefficients in the balanced equation, right? So just make sure your equation is balanced and that's it. You just fill it in. All right, so that's it for the video. Don't forget to complete the second part of this assignment, which is just a few example problems. I also want to take a moment to tell you guys that you did a wonderful, fantastic job on your flip grids. I really enjoyed hearing your voices and seeing some of your faces, and I look forward to continue grading the responses that you gave one another. And I also want to thank you guys for filling out the Google form. You gave me some awesome feedback to work with. When I say awesome, I don't mean like both positive and constructive feedback. And one of the suggestions I got was to end my videos with a chemistry joke, which I loved. So here we go. What's the dullest element? Borium. Get it? Boreum, bored, dull, haha. All right. I hope you guys aren't bored at home, and I hope you're keeping yourselves busy and having fun. And that's it. So until we meet again, have a wonderful day.